Hello everyone. So let's discuss grammar. So why we study grammar? If you have remember, when I discuss syntax analysis phase, this syntax analysis phase required grammar and the input which is coming from lexical analysis phase, and it will convert the input into parse tree. Okay. So syntax analysis phase required grammar. That's why we study grammar in compiler design. So what is grammar? Grammar is the combination of four terms: capital V, capital T, capital P and capital S, where capital V denotes variable or non-terminal. I will tell you shortly what are these symbols basically uses in a grammar. But first of all, you have to know their full name, particular what these terms represent. So capital T represent terminal, capital P represent production, and capital S represent start symbol. Okay, so grammar is the combination of four terms: VTPS, variable, terminal, production and start symbol. For example, I have a grammar like E tends to E plus E, or E star E, or simply ID. So this grammar can be read as expression is expression plus expression, or expression into expression, or simply an identifier. Now in this grammar, if I want to identify the four different terms, then variable, which is capital B, is here capital E, production, these three rules are nothing but production P, and terminal is the non particular alphabet which is in lower case. So plus, star and ID is the terminal in this grammar. Okay, so VT, this is P, and the start symbol is capital E. Okay, so we have identified the four terms in this particular grammar. Okay, now after that let's understand the classification of grammar. So grammar is individually classified into two types each. First of all, grammar is classified in ambiguous and unambiguous grammar. Okay, then grammar can also be classified as a deterministic and non-deterministic grammar. Okay, and the third way is grammar can also be classified as a left recursive and right recursive grammar. And all these types of grammar are independent, means grammar can either be ambiguous or unambiguous. A grammar can either be a deterministic or non-deterministic. A grammar can either be a left recursive or right recursive. Okay. So what is the sequence in which we study all such type of grammars? First we have to cover the ambiguous and unambiguous grammar. Then after we will study deterministic and non-deterministic grammar. And finally we study left recursive and right recursive grammar. Okay. And also we study how to convert ambiguous to unambiguous grammar. Okay. Using associativity and precedence rule. Then we will study how to convert non-deterministic grammar to deterministic grammar using the particular rule which I will give you in other videos. And we also studied how to convert a left recursive grammar to right recursive grammar using left factoring method. Okay, using left factoring method. So you just pause the video and note it down. After that we will study ambiguous and unambiguous grammar. So first is ambiguous grammar. So in ambiguous grammar, if there a grammar which have a particular string and that string have more than one leftmost derivation, more than one rightmost derivation, or more than one parse tree, then that grammar is called ambiguous grammar. So if grammar have more than one leftmost derivation, in short form it is called as LMD, or rightmost derivation, in short it is called as RMD, or more than one parse tree. Okay, so let's understand this definition with the help of example. So I will take the previous example. The example is E derives E plus E, or E star E, or simply ID. Okay, and let's take a particular string W is equal to ID plus ID star ID. Can this string have more than one left LMD, or more than one RMD, or more than one parse tree? Let's check it out. So first I have to test for LMD, leftmost derivation. So W is equal to ID plus ID into ID. How to derive a string with the help of a grammar? So you have to start from the start symbol E. E tends to E plus E. In leftmost derivation, the leftmost variable in the right production is evaluated first. So in this particular right direction, right hand side, the rightmost variable is this E. So I have to derive this E. E can be E. So I can use here E star E, and now this, for this E I can use E plus E, and the remaining is as it is. So E plus E into E. Now after that I will replace this E by ID star E, and then in the next step I will replace second E by ID star E, and the finally I will replace third E by ID. So I will get my desired result, ID plus ID into ID. Similarly, this string can also be derived in other way by using leftmost derivation, I will use E plus E instead of E star E. Here I will use E star E, here I will use E plus E. And then in this particular E, I will use ID plus E. In the next step, I will use E star E in place of this E. Okay, and then ID plus ID into E, and then ID plus ID into ID. Okay, so I will get the same result with the help of leftmost derivation, and it is more than one times. So definitely this grammar is ambiguous grammars. Let's check for rightmost derivation also and parse tree also. So according to rightmost derivation, first I will use the production E plus E. In rightmost derivation, you will replace the rightmost variable in the right hand side with the using other terminals or reproductions, using other productions. So here E plus E, this particular E in the right hand side, the rightmost E is have been replaced first. E plus E star E. Now E plus E, this E has been replaced by ID, E star ID. Then after E plus, now this time this E has been replaced by ID, ID star ID, and finally this E is replaced and we got the result ID plus ID into ID. Similarly, I can derive in other way also. E tends to A star E. This E can be replaced by ID. Now in the next step, this E can be replaced by E plus E star ID, and finally it is ID into ID, and then ID plus ID into ID. Okay, so in rightmost derivation we also got the same result but in two different ways. So definitely this grammar is rightmost derivation. Coming to the parse tree, you note it down here, parse tree. So how can we construct the parse tree for this string? Parse tree for this string will look like this. E derives E plus E, then this E can be replaced by E star E. Okay, and then this E can be replaced by ID, this E can be replaced by ID, this E can be replaced by ID. Okay, similarly you can also construct in other way. E derives E star E, then this E will derive E plus E, this E will derive E plus E, and then it is replaced by ID, ID, and finally ID. How to traverse the parse tree? You can traverse the parse tree from top to bottom, left to right. So whenever I traverse this parse tree, I will get the same result, ID, then again ID, so ID plus ID, then star, and finally ID. Here also I got the same result, ID plus ID into ID. Okay, so any grammar which is unambiguous is not parsed by any of the parser except one parser, which is operator precedence parser. So in the previous video I already told you operator precedence parser allows some ambiguous grammar. But apart from the operator precedence parser, all of the parsers does not allow the ambiguous grammar. So we have to change the ambiguous grammar. We have to convert ambiguous grammar into unambiguous grammar. What is unambiguous grammar? In unambiguous grammar, we have only one leftmost derivation or rightmost derivation on parse tree for any grammar. Like this grammar, if you convert the grammar into unambiguous, then for any string you will get only one leftmost derivation or one rightmost derivation or one parse tree. Okay, so unambiguous grammar, strictly speaking, it is the grammar which have only one LMD or one RMD or one parse tree. Got it? Okay. So in the next video we will see how to convert ambiguous grammar to unambiguous grammar.